this video, we are going to look at multiple choice questions 3 for physical sciences. Okay, we are still gonna follow the same method, which is to determine the wrong answers first, and possibly come up with the right one from there. Okay, question 1.1 goes, which one of the following is an alkane? So now here you have two options. Either if you already know the formula of an alkane, you can get the answer simply, but if you don't, you try to draw each of these and you'll see which one is an alkane. So the one that will form single bonds only will be an alkane. But if you already know the general formula for an alkane, which is CnH2n plus 2, then you will know that you're looking for one molecule which has a number of carbons. So we take the number, multiply it by 2, then the answer that you'll get will, you add 2 to it, then that will be an alkane, that kind. Right, so A, we have C6H8. So the 6, if you multiply it by 2, that is 12, plus 2, that is 14. So A is kind of wrong. It's definitely not an alkane. B, we have C6 and H10. So 6 times 2, that's 12. And instead of adding 2, they subtracted 2 there to get 10. So that implies that B is actually an alkyne, because remember the formula for an alkyne is CnH2n minus 2. Then if you look at C, that is C6H12. 6 times 2 is 12. So C6, that is like CnH2n. That is an alkene, not an alkyne. Then D, obviously that's what we have been looking for. That is the answer. So for question 1.1, the answer will be D. 1.2, esters are formed by a reaction between two organic compounds, X and Y, each with a different functional group. The functional groups of these compounds are, okay, unfortunately with this one, you'll need to know your esterification reaction. So esters are formed through esterification. Remember, where we react an alcohol with a carboxylic acid. For instance, you react methanol with ethanoic acid, you'll get what? Methyl ethanoate. Okay, so now what did I just mention? So those two reactants that I mentioned is basically an alcohol and a carboxylic acid. So here they're talking about the functional groups. You need to know your functional groups. So a functional group for an alcohol is what? It's a hydroxyl. Then for a carboxylic acid, that is a carboxyl. So it means there the answer is definitely A. Why is it not B? They say hydroxyl group. Yes, that's for an alcohol, but carbonyl group is not for a carboxylic acid. That is for a ketone. So B is wrong because they're implying that we are reacting an alcohol with a ketone, which is wrong. C, hydroxide ion with a carboxyl group. Yes, carboxyl group is for a carboxylic acid. But then hydroxide, no. D is definitely wrong. So that's out. So the answer is A. 1.3, when butane is subject to high temperatures and pressures, the following reaction takes place. Butane gives methane plus Y. Okay, so if you already know this, okay, for somebody who already knows that high temperatures and pressures, that is a form of cracking, that is thermal cracking, you know that Y has to be an alkene. But let's say you didn't know that. Well, there are many options here. You look at butane, you know butane has to have how many carbons? 4. Then methane has 1. So it means Y has to have 3 carbons. So you look for a compound there that has 3 carbons. A has 3, B has 3, C has 3, D doesn't have 3. So D is out. So we are left with 3 options, A, B, or C. Then now Y, so now how do you know, since those 3, let's say you didn't know that this is an alkene, well, what you can do is estimate, draw your butane, draw your methane, then you'll know that Y, because so far we know how many carbons Y has. So if you draw your butane, you draw your methane, and additionally you can kind of determine how many hydrogens Y has to have. So butane, if you draw it, you'll realize that butane has how many? 10 hydrogens. Methane only has 4, so it means that 10 minus 4, that is 6. So it means Y has to have how many hydrogens? It it needs to have 6 hydrogens. We already know that it has 3 carbons. So you look at those options. Is the answer A? No, because the hydrogens are 4 instead of 6. Is the answer B? No, because yes, it is indeed, because 2 plus 1 plus 3, yes, that's the answer. Is it C? Well, we have 8 hydrogens and we only wanted 6, so that one is out. So the correct answer there will be B. 1.4, a hydrochloric acid solution, HCl of concentration 1 mole per decimeter cubed, is added to excess powdered magnesium at 25 degrees Celsius. Curve 1 below represents the volume of hydrogen gas produced during the reaction. Okay, they didn't give us the reaction equation, but now, well, at least we know that hydrogen is actually formed. Curve 2 was obtained at different conditions using the same volume of hydrochloric acid solution. So now 2, let us see. So time, volume, change in volume over time. That implies that here this graph is of a reaction rate, right? And then if you look at 2, it is steeper than number 1. So 2 is steeper. And remember, the steeper the gradient simply implies that the reaction rate has increased. So 2 has a higher reaction rate. So now, which one of the following represents the conditions used to obtain curve 2? We have state of division, concentration, and temperature. And by the way, those are the factors that affect reaction rate. So now, since we see that 2 has a higher reaction rate, it means that we need there's a positive influence in all of them, okay? So the first one, state of division, ribbon. Okay, state of division, we have ribbon, powder. And if you have done this, you know that powder will actually have a higher reaction rate to cause the reaction rate to be higher, right? The reaction occurs faster, there's higher surface area. So the answer is either C or D. So you have ruled out A. No need to look for the other ones. Okay, now look at C and D. Concentration wise, they are the same, but the temperature is different. Now C has 20 degrees Celsius, D has 30 degrees Celsius. Now the higher the temperature, we know that the higher the average kinetic energy of the particles. More particles will have what? Kinetic energy that is equivalent or greater than activation energy, so the reaction rate will occur faster, more effective collisions, etc. So it means the answer there is definitely D. 1.5. In each one of the following reactions at equilibrium will the yield of product increase when the volume of the container is increased at constant temperature. Now here, remember, okay, so remember that the factors that affect the yield of when a certain reversible reaction is at equilibrium. So volume is not part of them, but volume, we know it is related to what? Pressure. And where there is pressure, we talk of gas. All of them are gases, fine, but pressure. Now, if you increase volume, you make the thing wider, so it means pressure decreases, right? There's now more space for the particles to like move around, so less collision, so pressure decreases. So if pressure decreases, according to Le Chatelier, that is going to disturb the equilibrium. But then remember, when you decrease pressure, we kind of favor the reaction that produces what? More moles, right? So we favor the one that produces more moles of gas. So in this case, we are looking for one which has more moles of gas on the product side than the reactant side. When you look at A, we have 1 on the left, we have 2 on the product side, so A is definitely the correct answer. If you look at B, there is 2, there's a balance there. C, there is 4 on the left hand side, there's 2 on the right hand side. Okay, so if you decrease pressure in that one, you will actually favor the reverse reaction. And here they said they want the yield of the product to increase, so it's not C. When you look at D, we have 3 on the left, we have 2 on the right. We are gonna favor which? If we decrease the pressure, the reaction will basically, the one that will be favored will be the reverse reaction. So the answer there is A. The other options are completely wrong. 1.6. Which one of the following statements is true for an exothermic reaction? Exothermic reaction, we know that it releases energy. So A, they say it is absorbed. No, that is for an endothermic reaction. B, more energy is released than absorbed. That sounds right. Let's see the other options. C, heat of reaction is positive. No, that is for an endothermic. D, energy of products is greater than the energy of the reactants. Well, that simply means that is the same as option C. Remember, change in heat of reaction is just change in the NH from products minus the reactants, the NH of the products minus the NH of the reactants. So if it is greater, it means, well, it's gonna, heat of reaction is gonna be positive as well there. So it means the correct answer there is B. 1.7, consider the equation below. Which one of the following is a conjugate acid base pair? Well, remember what I told you. You don't necessarily need to look at which one is the acid, which one is the base. In this case, we can see clearly that we just observe what formed from what, two molecules. We just pick two molecules that are actually the same, that look alike. So H3PO4 looks like the H2PO4. So you can see that that one actually came from the other. So now, do we have an option of those two together? No. So it means, okay, we don't have that option. Now H2O went with H2O plus, so they are related. Do we have that option? Yes. But now let's see which one was the acid, which one is the base. H3PO4 went from H3 to H2, so it means it lost hydrogen, meaning it was an acid. Then H2O was actually what? A base, because you can see that it gained a hydrogen, hence the H3O plus. So conjugate acid base pair there, the correct answer is gonna be, well, A. All right, okay, it's not, H3O is not the acid. Okay, it is the acid, by the way. Yes, it is a conjugate acid, since H2 was a base and we know we form a conjugate acid. Yes, so H2 was a base, so the answer is indeed A. 1.8, consider the balanced equation for the reaction below. Pick the oxidizing agent. All right, so the oxidizing agent, one thing that we know about it is that it undergoes reduction. So we want one of the molecules whose oxidation number has decreased, or in other words, one that has gained electrons, right? But remember, if you gain electrons, that simply means that the oxidation number is going to kind of like decrease, right? So here we look at that chromium, we see it was positive 2, then it went to positive 3. So now if it went up positive, it means it lost electrons. If it lost electrons, it means that is it underwent oxidation. So that is wrong. So it can't be chromium, that Cr positive 2 ion. If we look at CSN, it was positive 4, then it went to positive 2. It decreased, meaning that it gained electrons. How many electrons did it gain? Obviously, it gained 2 electrons. If it gained electrons, it means underwent reduction. And remember what we said, whatever undergoes reduction is the oxidizing agent. So in this case, the correct answer is going to be